Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Saidi Shu'aib bin Ahmad Latsfi. My metric number is 197844. Today I would like to present about internal energy by using Maxwell relation. The differential form for the internal energy given by du equal to TdS minus PdV. We also can express the internal energy in terms of du equal to delta U over delta S times VDS plus delta U over delta V times SdV. We can see that both equation is expression for du, and we can combine this equation in one equation. So we get delta U over delta S times VDS plus delta U over delta V times SdV equal to TdS minus PdV. We can see that both sides have ds and dv, and we can make it into one equation for ds and one equation for dv. For ds, we get delta u over delta s times v equal to t. For dv, we get delta u over delta v times s equal to negative p. Next step, we need to apply delta over delta v times s into both sides, and we get delta over delta v times s times delta u over delta s times v equal to delta t over delta v times s. Same also with this side, we need to apply delta over delta s times v to both sides, and we get delta over delta s times v times delta u over delta v times s equal to negative delta p over delta s times v. We need to apply this both sides because we need to make it same both sides, and we also assume that s and v as a constant. Finally, we get this into one equation. Delta over delta s times v times delta over delta v times su equal to delta over delta v times s times delta over delta s times vu. We can cross the u for both sides, and we see that this side is equal to this side and this side is equal to side. We can make the conclusion that this is equal to this. So delta t over delta v times s equal to negative delta p times delta s times v. I think they are from me. Thank you.
Okay, for atom P Maxwell relation for this type 2, take the derivation form of atom P dH equal to TdS and VdP, and consider the LPH as a function and of its natural variable S and P such that H equal to H as P. We can find the total differential of enthalpy from this. This one. Now equate this to the differential to get this equation, and then equating coefficient of ds and dp, we get this one, dh over ds p equal to t, and dh dp s v, and then differentiate both sides of the first of this expression with respect to p, but while keeping s constant. We get this one, and differentiating the second expression with respect to the s while keeping p constant p, and we get this one by equality of the mixed second order partial derivative. This expression are equivalent, so we have this one. This is our second Maxwell relation.
So hi doctor, I'm Liang. My metric number is 198369. So today I'm going to discuss about Helmholtz free energy Maxwell relation. So my task is given as the first equation here, df equals to negative p dv minus s dt, which I have to prove that this equation is same as the final equation here. So firstly, we have to consider f as the function of v and t. After that, we do the partial derivative for df. After that, we equalize the df to solve out this equation. After that, since we have dv and dt for both sides, so we can equalize dv and dt. So as for the first part, dv, the equation the equation that I've solved is delta f over delta v equals to negative p. As for the equation, second equation is delta f over delta t is equals to negative s. So next, let us assume that we multiply the first equation with delta s over delta t to let the s as the constant to sort out this first equation here, and we multiply delta v over delta s for the second equation to sort out this second equation here. So after that, we equalize the right hand side and the left hand side to sort out these two equations here. The first equation here is from the right hand side, and the second equation here is from the right hand side. These both equations are from is being proven that the first equation here is the same as these two equations. So thank you.
Hello, this is Lee, and I will explain the Gibbs free energy Maxwell relation. And the equation is dg equal to v delta p minus s delta t. And first step, let's consider the g equal to gpt. So dg equal to the delta g over delta p, t times delta p, plus delta g over delta t p times delta t. And let's equal with it, equal to, then we got the second equation. After that, we already know that delta g over delta p equal to v, and another one equal to minus s. So let's replace about it, and we got r delta over delta p times delta g over delta t p equal to minus delta s over delta p t. Then we got the result. So that's my part, and thanks for listening.